In yesterday's class, we have discussed about Nernst equation and how to derive Nernst equation and all. And actually, that class was a little lengthy because most of the some equation, the derivation part was there. To make you understand, I took a lot of time. Actually, uh, for competitive point of view, you have to understand the meaning of the reaction. That is the equation, Nernst equation. What is Nernst equation and what does it represent? And it's a final representation, right? And before Nernst equation, we have discussed about electrode potentials. Do you remember that? That means before last class, electrode potentials. This is a list of electrode potentials of different electrodes, metallic electrodes as well as non-metallic electrodes. My strong suggestion is all of you should have textbook with you and underline the things whenever I say this is important and that is important and the formulas, equations, tables, problems and everything. At the same time, you have to note down the things. Without notes, you should not, you don't attend the class. This is not the any entertainment program. This is a class, science class particularly, and so you should be with notes. See this table is very very important. And what is this table? This is nothing but it is a list of standard electrode potentials at 298 Kelvin of different electrodes. So here you see in the middle you can find a hydrogen electrode here, right? For hydrogen electrode, standard hydrogen electrode, what is the electrode potential value? 0. 0. Above hydrogen, the values are positive. These are all positive values. And below hydrogen, the values are negatives, minus, 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 and so on. And what is the electrode potential value of hydrogen? It is 0, right? And above hydrogen, all the values are positive. And you can find fluorine, fluorine at the top of this series. So its value is plus 2.87 volts. That means fluorine is having highest reduction potential. Which element is having highest reduction potential? Fluorine. So it has the highest reduction potential value and it is the most powerful oxidizing agent. You can note down. If the reduction potential value is higher, it is more powerful oxidizing agent. So that means it oxidizes other substances. All right. Next, if you come down, see at the bottom of this series, you can find lithium. Lithium, whose value is the least among the given electrodes. So that is minus 3.05. So it is a least value and least reduction potential value is for lithium. So it is a strong reducing agent. It's a strong or strongest reducing agent among all these elements given. So these 2 points you remember. So here hydrogen is there in the middle. Above hydrogen positive values. The highest value is for fluorine. Fluorine is a strong oxidizing agent. And below the table lithium is present, which is having the negative value and its reduction potential value is the least and it is a strong reducing agent. These are the points we need to remember. Then okay, what is the use of this electrochemical series? What is the use of this series of these electrode potential values? Suppose in the previous classes many times we discussed about galvanic cell. In that galvanic cell, we have used zinc as anode, copper as cathode. See here, where are these elements? See here, there is a zinc. Here, zinc, right? And whose value is minus 0.76 volts. Copper is having plus 0.34 volts. So this is a cathode. What you can understand from this? Once again, you see zinc is having minus 0.76 means lesser value, whereas a copper is having higher value, positive value. It is a cathode. What you can understand from this? The electrode which is having lower value is act as anode, is having higher value act as cathode. You can note down. Otherwise, you can also remember like this. And which process is taking place at zinc actually during galvanic cell? That is where we have discussed in the previous classes. Oxidation takes place at anode, right? Oxidation, and which is having lesser reduction potential value. If the reduction potential value is less, which acts as anode, and if the reduction potential value is higher, it acts as cathode. At anode, oxidation takes place. At cathode, reduction takes place. Please note down all these points, and these are very much helpful for you. And in your textbook, you can find two important points. A negative standard electrode potential. E naught means standard electrode potential. That is a reduction potential. Is a stronger reducing agent than hydrogen couple. That means if the negative value represents the stronger reducing potential, reducing agent, the positive value of electrode potential value, that is the reduction potential value, represents is a weaker reducing agent. Weaker reducing agent. Just I told you, fluorine is having higher value, is a good oxidizing agent, right? Okay, all these points we discussed in the last class. These are under the derivation of Nernst equation. Now come to the next topic, and this topic also we discussed, and all these formulas you have to remember. So this is the relationship between standard electrode potential and equilibrium constant Kc. E naught cell is equal to 2.303 RT by NF log Kc. You might have noted down all these formulas in a previous class. So you should know all these formulas. Now come to the today's topic, electrochemical cell and Gibbs energy of reaction. Electrochemical cell and Gibbs energy of reaction, right? Here, let's come to the formula directly. Then I will try to make you understand. Delta G is equal to minus NFE cell. Note down this. Otherwise, if you have textbook with you, underline that. So delta G, delta means change. G for Gibbs free energy. Change in Gibbs free energy is equal to minus NFE E cell. So what is this? So here N for number of electrons transferred during redox process, and that you will come to know. So here in this reaction, in the following reaction, Zn plus Cu plus 2 gives Zn plus 2 plus Cu. Here how many electrons get transferred? Zn becomes Zn plus 2, means zinc losing 2 electrons. Cu plus 2 becoming Cu. That means copper is gaining 2 electrons. So that means during this redox process, 2 electrons are being transferred. So that means the N value is 2 here. See here, we use 2. Okay, N is nothing but number of electrons transferred. F for Faraday. For Faraday, you remember 96,500 coulombs. That is the value of 1 Faraday. 96,500 coulombs. E is E for electrode potential of the cell. So if the EMF of the cell E and NF is the amount of charge passed. So E is the EMF of the cell, NF is the amount of charge, the total current we are passing through the electrolytic solution. And delta G naught, delta G is the Gibbs energy of the reaction. So then this is the reaction, right? This is the equation. Remember this. And how to apply this formula? See, for this reaction Zn, I told you. Suppose if the same reaction is given like this, 2Zn plus 2Cu plus 2. That means here you see 2 2s are 4, no? Here Cu plus 2 is there, but it is multiplied with 2, no? Then 2 2s are 4. That means total number of electrons transferred is 4. So in this formula, we have to substitute 4 in the place of N. Delta G is equal to NFE, no? In the place of N, we have to substitute 4 here. But you no need to worry about all these things, and you can easily identify how many electrons are being transferred in any reaction. Just you keep on listening, try to understand. If any one of you get any doubt or difficulty during my explanation, you can ask me. Okay, this is a live class, this is not a recorded class, right? So you can ask me. That's the purpose of live classes. Now, you see here one more important, very important formula we are going to get. If the note it down, note down. If the concentration of all the reacting species is unity, if the concentration of all reacting species is unity. Unity means what? 1. What is the meaning of this sentence? If you use a zinc sulfate solution whose concentration is 1 molar, molarity is 1. Copper sulfate solution concentration also 1. If the concentration of the solutions we are using, if the concentration is unity, then E becomes E naught cell. E becomes E naught. That means in the above formula, delta G can be written as delta G naught. Delta G naught is equal to minus NF E naught. What's the difference? Just nothing. So here just we have used delta G minus is equal to minus NFE. Here delta G naught is equal to minus NFE naught. Here this 0 we use, that means these are the standard conditions. The standard, the change in standard, change in Gibbs free energy is equal to minus NF E naught cell. That means standard electrode potential of the cell. So that's the measurement of E naught cell. We can obtain the important thermodynamics. Okay. Now remember this formula. This is important form. And next one. This here one more important formula. Delta G naught is equal to minus RT ln K. Note down this formula also. Delta G naught is equal to minus RT ln K. What is this? R means gas constant, 8.314 joule per mole per Kelvin. T is a temperature. This is logarithmic form. Ln means natural logarithm. K is equilibrium constant. K is equilibrium constant. Right? Here all the things are given here. Delta is standard Gibbs free energy and equilibrium constant, everything is given. And here one small formula, one problem is given based on this formula that we have discussed above. Delta G naught is equal to minus NF E naught. One small problem, solved problem is given. Let's go through this problem little quickly. Standard electrode potential of Daniell cell is 1.1 volts. Standard electrode potential means E naught. E naught value is given. What is the E naught value given in the problem? 1.1 volt. Calculate the standard Gibbs energy for the reaction. What we have to find? Gibbs energy. Delta G naught we have to find. So E naught value given, G naught value, delta G naught value you have to find. Which relation we have with us? We have this relation, that is delta G naught is equal to minus NF E naught. Is a very simple, no? Very easy, no? See here. Delta G naught we have to find. Delta G naught is equal to minus NF E naught. What is the given reaction? Zinc Zn plus Cu plus 2 gives Zn plus 2 plus Cu. How many electrons getting transferred here? See here, very easy. See here, zinc 0, no? Here zinc plus 2. 0 to plus 2 means 2 electrons getting transferred. That means N value is 2. So substitute N value 2 in this formula. What is F here? F is nothing but Faraday. What is the value of Faraday? 96,500. Here 96,487 is given. No need to take that value. You take directly 96,500 coulombs per mole. Right? And E naught value already given in the problem, 1.1 volts. So 1.1 volt. Substitute all these values. Delta Z naught is equal to minus 2 into 1.1 volts. 1.1 means E value is substituted before. Then F value, that is 96,500. If you multiply all these things and you get finally 21,227 joule per mole This is the answer you get actually. And if you want to convert this into kilojoules, then divided it by 1000, then you get the answer in kilojoules. Then this is the value we get. Okay. So it's likewise you can easily calculate just by applying this formula. This is a very basic question, and first you practice if you have textbook with you. Otherwise, after this class, I will share the PDF of this chapter in our WhatsApp group. Then you can go through that. Now let's discuss the some in-text questions. In-text questions are very important both for board exams as well as for your competitive exams. And some problems directly will be given in competitive exams from in-text questions. And I'll just now, just 5 minutes back, I have shared the PDF file of solutions to these in-text questions in our WhatsApp group. So just you go through that after the class. Whenever you get some difficulty, whenever you want to refer, go through that file and note down. See here 3 problems are given. Let me explain these problems little quickly. Calculate the potential of hydrogen electrode in contact with a solution whose pH is 10. This is an important question. Calculate the potential of hydrogen electrode. We have to find E value of hydrogen electrode whose pH value is 10. pH is 10. Okay. And for this, I'll open my tab. Okay. So you can see the solution of this, and the same thing I have shared in our WhatsApp group. Later you can download and you can use that solution and all. This is the question given, right? Uh, Actually, when pH value is given as 10, no? pH is 10. In first year, that is in 11th class, in the chapter ionic equilibrium, that is acids and bases, you might have come across one formula, that is pH is equal to minus log H plus concentration. This is the basic formula. Otherwise, one more formula you might have come across. H plus ion concentration is equal to 10 to the power of minus pH. These are the two formulas you might have got, right? Now let's take this formula. H plus ion concentration is equal to 10 to the power of minus pH. Okay. Now let's apply this formula. H plus ion concentration is equal to 10 to the power of minus pH minus, what is the pH value is given in the question? pH value 10. So in the place of pH, let's substitute 10. That means 10 power minus 10. So we got H plus ion concentration. So for this, we have to apply this formula that we have studied in 11th class. If you don't know, please note down. H plus ion concentration is equal to 10 to the power of minus pH. We have substituted pH value, we got this. Now let's come to Nernst equation. What is Nernst equation? You see here, Nernst equation. Nernst equation is this, and electrode potential of hydrogen is equal to standard electrode potential of hydrogen minus RT by NF ln 1 by H plus ion concentration. You no need to worry, when you no need to remember this, apply this formula. You directly apply this formula, second one. Electrode potential of hydrogen is equal to standard electrode potential of hydrogen minus 0.059. Okay, can you see this? Minus 0.059 by 1 log 1 by H plus ion concentration. Okay, this is the Nernst equation that we discussed in the last class. So this is for hydrogen electrode. Okay, come on. This we have to find. Electrode potential of hydrogen is equal to, what is the value of standard electrode potential of standard hydrogen electrode? Its value is 0, no? for standard hydrogen electrode potential for standard hydrogen electrode is 0. So this value becomes 0. And what is left here? 0.0591 by 1. Why we apply 1 here? We apply 1 because n value is 1. N value is 1. Why n value is 1? H plus gains 1 electron, becomes half H2. Here number of electron transferred only 1. So n value is 1. So 0.0591 by 1 into log 1 by H plus concentration. So I hope you understood this. And next log 1 by 10 to the power of minus 10. Log 1 by 10 to the power of minus 10. Sorry, 1 second. One second, I have lost my connection here. Okay, you can able to see now? Right. See here, 1 by log 10 power minus 10. If you take this 10 power minus 10 to the, sorry, there is some fluctuations in my net connection. Okay, now you see this log 1 by 10 power minus 10 becomes log 10 power 10. If you take to the numerator, 10 power minus 10 becomes 10 power plus 10 if you take to numerator. This is log 10 power 10. This becomes 10 log 10 now. 10 into log 10. I will write here, see. Log 10 power 10 can be written as 10 log 10. Do you know this? Suppose if you don't know, please let me know. You just message me in our WhatsApp group. I will take a separate class on logarithmic values and some tips and tricks in calculating the numericals little quickly. Okay, that separately one class we will have so that you can calculate easily. Logarithmic values and anti-logarithms, these are the very important thing in certain to solve this type of questions. See, log 10 power minus 10 can be written as 10 log 10. What is the value of log 10? Log 10 is 1. So this becomes 10, right? It becomes 10. See here. So totally this becomes 10 and 10 into 0.0591, that becomes 0.591. Here this part becomes 10 minus 0. Minus 0.0591 into 10. What is the value? Minus 0.591. This is the answer. That's all. Okay. Once again, you go through the material and if you feel any difficulty, you can ask me. Next question is this. This is the next question given in your textbook. I'll go little fast. Nickel 2 Ag plus concentration is given here. Nickel plus 2 concentration is given plus 2 Ag. And standard electrode potential of cell is given. Standard electrode potential of cell value 1.05 volts. Okay, what we need to find? Okay, calculate the EMF of the cell. We have to find EMF of the cell. So to find EMF of the cell, we have to apply Nernst equation. According to Nernst equation, EMF of the cell is equal to standard electrode potential of the cell. What is the value of standard electrode? It is already given in the problem. See here. Standard electrode potential of the cell is 1.05 volts. Is already given. Minus 0.0591 by N log nickel plus 2 concentration by Ag plus concentration square. Why we have to write like this? I told you in the last class, product concentration by reactant concentration. Here what is the product? Actually two products are there. but this is a metal, no, solid. We should not consider solids, right? This we should not take, and this nickel also we should not take. Only nickel and Ni plus 2 Ag plus. So what is the product? Ni plus 2. Ni plus 2 concentration by Ag plus concentration square. Why we have to write square here? Because 2 Ag plus is given 2. If it is 3 Ag plus, then we have to write cube here. Okay. What is the Ni plus 2 concentration? Ni plus 2 concentration is 0.10160 by Ag plus concentration 0.002 square. Why? Okay, 2 moles are there, no, square. And if you simplify this, here you have to do this calculation, because if everything I want to do means it takes a lot of time. You practice yourself. If you feel any difficulty, let me know. I'll explain you in a simple manner. So if you modify this, the 0.002 square becomes 0. Here already 2 zeros are there, no? 2 zeros becomes 4 zeros because we are squaring, no? 2 becomes 4. Here 2 zeros becomes 4 0. 1, 2, 3, 4. 4, and this here some mistake is there, and in a square 2 square becomes 4. Okay, you modify yourself, then you will get the correct answer. And here you get this one 16.16, no, 0.16, it appears as 16. Here it appears as 4. 4 ones are 4 fours are, so that finally becomes this is a 10 power 4 log, okay, its value is 0.059 by 2, 0.059 by 2, 0.02955 something you get, and this is its value, and log 0.16 by 0.16 by 0.0004, it becomes. Do you have any problem here? I will tell you. This part I will explain. This part I will explain. Log 0.16 by 0.00004. Okay, and that is equal to log I can write 16 into 10 power minus 2 by, because after decimal point 2 digits are there, no, so 16 into 10 power minus 2 by, here 4 into here how many digits are there? 1 2 3 4 5 6, 10 raised to minus 6, 10 raised to minus 2, 10 raised to minus 2 get cancelled. Here 10 raised to minus 4 will be there. Then it becomes log 16 by 4 into 10 raised to minus 4. This 10 raised to minus 4, if you take to numerator, it becomes 10 raised to plus 4. So log 4 ones are 4 fours are 4 ones are 4 fours are. One second. I write directly log 4 into 10 raised to 4, that is equal to log 4 value 0.6021 plus this log 10 raised to 10 power 4 becomes 4. 4 log 10, 4 log 10 becomes 4. Okay. If you know this simplification, you can find easily. This is 4 plus 0.6021, and here minus 0.02955 you get. And if you simplify all these things, finally you get this. And if you feel any difficulty, you just message me. I'll explain these logarithmic conversions and all in the coming classes. So here one more problem is given, 3.6. You try to solve this, and I'll go little fastly. Here you get anti-logarithm also in this problem. See here, at the end you can find, you have to find anti-logarithm. I'll go little fast here. See what we need to find. The cell is given here, and calculate the standard Gibbs energy and equilibrium constant of the cell reaction. We have to find Gibbs energy, that means delta G, and equilibrium constant. And we still have 7 minutes, 7 minutes of time. I'll try to do this little fast. What is the formula to find Gibbs energy? Just in the beginning of this class, we discussed delta Z naught is equal to minus NF E naught. Delta Z naught is equal to minus NF E naught. Right? What is the N value? What is the N value in this reaction? See here, 2Fe plus 3. 2Fe plus 3. Here 2Fe plus 2. Then I will tell you how to find N value. 2Fe plus 3 means 2 3s are 6. 2 3s are 6. 2Fe plus 2. 2Fe plus 2. 2 2s are 4. Here 2 3s are 6. Here 2 2s are 4. What is the difference? Here 6, here 4. The difference is 2, no? That is the value of N. N value 2. Otherwise, you can take this part also, oxidation part. 2I minus means 2 units of negative charge. Here it becomes 0. 2 negative charges become 0 means N value is 2. The first one is better, I think. N value is 2. So in delta G naught is equal to minus N value is 2. F value is 96,500, we know, 96,500. What is E naught value? Standard electrode potential of the cell. It is given in the problem itself, 0.236 volts. It's already given in the problem. So just substitute the values and you will get the final answer. That is the answer you get in terms of joules. If you want to convert this into kilojoules, okay, you can do it. So 45,441.864 joules you got, right? Next, come to the second part. What is the second part of the question? Second part of the question is we need to find equilibrium constant. Equilibrium constant. Just a few minutes back, I told you one small formula, this one. If you don't know, please note down. Delta G naught is equal to minus, I'll write now, I'll write here. This is the actual formula we discussed just a few minutes back. Delta G naught is equal to minus RT ln Kc. RT ln Kc. Here ln can be converted into log. This ln is natural logarithm, can be converted into log by multiplying with 2.303. When you use this 2.303, then a ln becomes log Kc. So this is the formula is given in your material. So here, see here, this is the formula. What we need to find? We need to find log Kc, no? So log Kc is written here. Log Kc is equal to minus delta G naught by 2.303 RT. Okay? Do it yourself, at least later. If you cannot now, you do it later and you can find the relation. See here. This is the formula. And here log Kc we need to find. Log Kc is equal to minus. Here already minus is there, minus. Delta G naught become, you send all this part 2.303 R2 to the left hand side and it go to the denominator. Now substitute the values. Delta G naught value minus 45.54. Where do you get this? Just we have solved, no? Delta G naught value you got, no? This answer, whatever the answer you got here, that you substitute in the place of delta G. 2.303, R value 8.314, temperature 298. Temperature is given 298. So if you substitute all these values and finally you get 7.981. 7. What is the what's the value? What is this? This is nothing but log Kc. Log Kc is equal to 7.981. Actually, we need to find Kc. If log Kc is 7.981, then Kc is equal to anti-log of 7.981. We have to find anti-log of this. Then finally we get Kc is equal to 9.57 into 10 power 7. Here I cannot explain you how to find anti-log and all in this class, and I will take a separate class of this. Otherwise, at least I make a separate video on this topic, and how to get the values of anti-logarithmic values, and what is the basic logarithmic formulas that you have to be perfect with, that we'll discuss later, right? So, dear students, this is a small topic but yet important. Actually, in the chapter electrochemistry, these are the topics that most of the students feel little bit difficulty. Okay, I know that understanding these concepts in a single class like this may be little bit difficult for you, though you do little work on it, and if you repeatedly do 2 or 3 questions similar to this, you will get command over the topic. Here basically the important thing is you have to be perfect with the formulas, and you have to understand the formula where we need to apply that formula. You see, in the particularly in today's class we got 2 important formulas related to delta G naught. Delta G naught is equal to minus NF E naught, and the second formula that we have used just now, delta G naught is equal to minus 2.303 RT log Kc. This gives the relationship between Gibbs free energy and equilibrium constant. So these are the formulas, and the time is it's almost going to over. Okay, we'll continue the class in tomorrow. Okay, and tomorrow is a separate topic. Since actually I would like to start that topic also,